In this tutorial, from JAK Services, we'll walk through how to get started with an ESP32 microcontroller and use one of its GPIO ports to drive a blinking diode. When you first connect the ESP32 to your computer using a micro USB cable, your computer may not detect it. The ESP32 communicates over USB through a UART interface provided by a USB-to-UART bridge chip, most commonly the CP2102 from Silicon Labs, see item 4 highlighted in the image. If the Silicon Labs driver is not installed on your system, the board will not be recognized. To verify if the driver is installed on a Windows computer, open Device Manager by pressing the Windows key +X, then pressing M. Next, connect the ESP32 development board to your computer using the micro USB cable. If a new COM port appears, similar to the one highlighted here, then the driver is already installed, and you can proceed directly to setting up your development environment. If no new port appears, you'll need to install the Silicon Labs driver manually, using the URL shown here. Navigate to the Download section and select the driver appropriate for your system. In this tutorial, we use the CP210X Universal Windows driver. Once the zip file has downloaded, extract its contents. Then, right-click on the scilabsr.inf file and select Install to begin the driver installation. When the installation is complete, unplug and reconnect the ESP32 board, and verify that it now appears in Device Manager. Once your computer successfully detects the ESP32, you're ready to start programming the microcontroller. There are several IDE options available for ESP32 development. At one end, Visual Studio Code offers native machine code compilation, advanced features, and a high level of control. At the other end, MicroPython provides a lightweight, interpreted Python runtime that runs directly on the microcontroller, making it ideal for rapid prototyping and interactive testing. However, because it is interpreted, MicroPython may not be suitable for more demanding applications such as high-speed sensor sampling, fast Fourier transform processing, etc. For this tutorial and quick mock-up to make a blinking LED using a GPIO port, we'll use MicroPython. See this URL for the documentation, along with the Thonny IDE, especially well suited for beginners, which can be downloaded from this URL. Once Thonny is installed, reconnect the ESP32 development board and launch the Thonny IDE. From the menu, select Tools, Options, and then Interpreter. In the first drop-down menu, choose MicroPython ESP32 as the interpreter, and select the appropriate COM port for your ESP32 board. Leave the default checkboxes enabled. Next, press and hold the boot button on the ESP32 board while clicking Install or Update MicroPython ESP tool. This ensures the firmware is correctly installed. When the installation completes, click Close, then OK. At this point, your ESP32 is ready and we can test with a small LED blinking mockup and this test script to verify everything is working. As long as the board is connected to the computer by USB, no external power supply is required for testing. During development and debugging, it's often more convenient to run scripts directly from the computer rather than flashing them permanently to the device. To execute the script, simply click the play button in the IDE. As shown here, using GPIO pin 16, connected through a 390 ohm resistor in series with an LED to ground, the LED blinks brightly at half-second intervals, confirming the installation of the mockup. Now that the code works, we can flash it to the MCU so it runs automatically when the ESP32 powers up. Connect the board to your computer, open Thonny, and choose File Save as MicroPython device, then save the script as main.py so it runs at startup. After that, press the reset button, or unplug and reconnect the board, and the LED should begin blinking. In the script, we added two Python print debugging statements inside the blinking loop. One prints 1 when the LED is set to 1, and the other prints 0 when the LED is set to 0. These messages are sent over USB, so if you start Thonny after the board is powered up and already blinking, the printed values will appear in the Thonny shell window. We can also use other serial port applications, such as PuTTY or TerraTerm, to view the print values sent by the flashed script as can be seen here. Just remember that only one program can use the USB serial port at a time. If you want to replace the existing startup program on the ESP32, save your new script to the device as main.py and overwrite the existing file. After saving, press reset or unplug and reconnect the board, and the new script will run at startup. Occasionally, you may find that you need to reinstall MicroPython from the Thonny options to make this work. If so, remember to hold the boot button during installation. The content of this tutorial, along with related links and scripts, is available on the JAK Services website. I hope you found this video useful. If so, don't forget to like and share.